All right, let's talk about a problem that just about every successful app runs into. A database build that starts to look, well, kind of terrifying. But don't worry, there's also a really elegant solution that doesn't just save you a ton of money, but also makes your application crazy fast. Let's dive in.
So let's set the scene. We've got Timothy, a junior developer, and his senior colleague, Margaret. Their company's big flash sale is a massive hit, which is great, but it's also creating a new, very expensive problem. Timothy is staring at their cloud bill, and the numbers are just making his eyes water.
So he goes to Margaret, and he points out the culprit. It's their #1 best-selling item, a mechanical keyboard. See, every single time a customer lands on their homepage, the app has to go and ask the database for all the keyboard's details, and that's happening a lot.
Yeah, you heard that right. 400,000 times in a single day. That's 400,000 individual, expensive trips to their main database. But what makes this number truly mind-boggling is the why behind it.
Right. The price, the name, the description, all of it has been completely static. It hasn't changed at all. They are burning through cache, asking the database the exact same question over and over again for an answer they already know. And this leads Margaret to a very simple but very powerful realization.
And that just nails it, doesn't it? You're paying for a powerful, sophisticated, and expensive database to do the world's most boring, repetitive job. There has to be a better way to do this. And lucky for Timothy, there is.
Margaret's solution is to introduce a high-speed memory layer. The idea is simple. Instead of constantly bothering the slow, expensive database, they'll put a super-fast, much cheaper service in front of it. And that service is Amazon ElastiCache.
Now the magic words here are in memory. ElastiCache uses RAM, which is basically your computer's short-term memory. It's blazing fast. A traditional database uses a disk, which is more like a library. It holds way more stuff, but finding what you need takes a lot longer. That's why ElastiCache can give you an answer in less than a millisecond.
So let's really spell it out. A database, on the left, is all about durability. Its job is to keep your data safe no matter what. A cache, on the right, is all about speed. It holds a temporary copy of your data for lightning-quick access. You're basically trading a little bit of permanence for a massive gain in performance where it counts.
Okay, this sounds great in theory, but how does it actually work in the code? Well, Margaret decides to use a really common and powerful design pattern called cache aside. Let's see how that's put together.
The logic here is actually pretty simple. Your application basically becomes the traffic cop. Before it even thinks about going to the database, it first asks the cache, hey, do you have this? And that question leads to one of two outcomes, a cache miss or a cache hit.
So let's trace the very first request for that keyboard. The application checks ElastiCache, but of course, it's empty. That's a cache miss. No big deal. The application then does what it always did. It goes to the main database and gets the data. But, and this is the crucial part, before it sends that data back to the user, it saves a copy in ElastiCache for next time.
Now, what about the next customer? And the 399,999 customers after that? Well, their requests go to ElastiCache, and this time, bam, a cache hit. The data is sitting right there, ready to go. It gets returned in under a millisecond, and the expensive database is never bothered at all. It just gets to relax.
So this concept of hits and misses is absolutely central to caching. But, it sounds a little too good to be true, doesn't it? Timothy quickly realizes that solving one problem has created a new and very famous challenge.
I mean, just let that sink in for a moment. For that one popular keyboard, they have gone from 400,000 database reads down to essentially 0 after that first request. The cost savings and the speed improvements are just enormous. But of course, there's a catch.
And this is the million-dollar question that Timothy asks. If the marketing team updates the keyboard's price in the main database, but the old price is still sitting in the cache, uh-oh, now you're showing customers outdated information. And that's the hard part of caching.
In fact, there's a famous saying in the developer world that sums this up perfectly. Figuring out when to get rid of old, stale data from your cache, a process called cache invalidation, is notoriously difficult. So how do they solve it?
Well, most of the time, you use a simple but really effective tool called a time to live, or TTL. Think of it like a self-destruct timer. When Margaret's code saves the keyboard data to the cache, it also attaches a note that says, hey, this is only good for 1 hour. Once that hour's up, ElastiCache just deletes the item automatically.
And this right here is the fundamental trade-off. You're making a conscious decision. You're accepting that for a little while your data might be slightly out of date, but in exchange you get incredible performance and the ability to handle huge amounts of traffic without breaking a sweat. And for most applications, that's a trade you'll want to make every single time.
Okay, let's bring it all home. What are the key lessons you should take away from all this?
Well, first, you're going to dramatically slash your database costs. Second, your users get a way faster, way better experience. Third, you're building a protective shield around your database so it doesn't fall over during a traffic spike. And finally, your whole system just becomes more scalable and more resilient. It's a win all the way around.
And hey, here's a little pro tip for you. For your absolute most popular items, you can preload them into the cache before any user even shows up. It's a technique called cache warming, and it ensures that even the very first person gets that awesome, lightning-fast cache hit.
And that brings us to the final thought I want to leave you with. Now that you've seen how powerful a simple caching layer can be, I want you to think about your own projects. Look at your own code and ask yourself that same question Margaret did. Where exactly are you paying your database to repeat itself?